Okay, hello guys, welcome to the third number sense video I made. Okay, so in this video, we will be talking about multiplying numbers that end with 5. Examples include 5, 15, 225, all that stuff. So now let's start. Well, first let's define some numbers. Let's just represent A and B as any whole number. What is a whole number? Basically, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Those are all whole numbers. It's important to remember that 0 is a whole number. Non-examples we include decimals like 1.23, negative numbers, -2. Of course, you could use these numbers, but it's not appropriate to the situation. Negative numbers, you multiply them the same way. But I would not be messing with negative numbers. It's just basically the same thing. -15 times 15 is the same numerical value as 15 times 15. It's just that it has a negative value. It's just a negative. And another non-example would be like a number keeps on going forever, like pi 3.141592653. Okay, so basically we represent 15, 25, and those numbers as 10a plus 5. And like I said, a is any whole number, and 10a plus 5, like I said, is 5, 15, 25, 75, blah, 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 blah. Okay, moving on. Okay, so hopefully here, what I want you to see is what all these numbers have in common. You're squaring these numbers. When you square a number, you basically multiply times itself. What happens when you multiply a number that ends with 5 by itself? Well, you get 25 in the end. Of course, there's some not so obvious pattern in the first digits, but that's a little more advanced than what I'm trying to teach. Well, the thing I want to note is that they always end in 25 if you square them. Okay, so now let's make this into a formula. Okay, so 10a plus 5, like I said, it represents any number ending in 5, 15, 25, 35. So now what happens when we multiply it by itself? Well, we basically get this long formula. And this looks ugly. We want to make it look better. So here is a simple version of an easier to look at version of the formula. As you can see, you're multiplying a times itself plus 1. So like, let's say you're multiplying 15 times 15. The 1 is going to be the a. 1 times 2 is 2. And you're just multiplying times 100. That's 200 plus 25 to 25. Okay, and here I rewrote the formula, but in an easier to look at form. First you get the a. Here I did some examples. 75 times 75. Well, the 7 would be the a. The 8 is the a plus 1. What's 7 times 8? Well, 56. There you go. That's your first numbers. And then you just add that 25 in. And of course, like in elementary, they just forced you to learn up to the 12 times 12 multiplication tables. Well, most people anyways. And you should know that 11 times 12 is 132. 132 times 100 is this. 132 with two zeros. And of course, since you're multiplying these two, the last digit is going to be 25. That's 132, 25. Okay, easy. Okay, so now we want to think of this in a general form. 10a plus 5 is your first number, and 10b plus 5 is your other number. They are two different numbers. Of course, it can be the same number, doesn't matter. But this is a more general way of saying it. So now what happens when you multiply these two? Well, you get this long formula. 4 terms in it. And what you can do is actually factor it out like this. Put the 100, factor out 100, you get, well, like it's already like sort of like that, but whatever. This is going to define your first, well, it's not going to define your first term, but because there's a 50 here, a 50 is a very big number and it grows as these two numbers grow. But what I want to point out first is that this 25 is no longer just a 25, because you can add a 50 and it will become a 75. I just ignore the first term right now. Let's say a plus b is 1, right? So 50 plus 25, that's 75, because a plus b is 1, which is odd. Let's say a plus b is 2, which is even. 2 times 50 is 100. That will give you 125. Easy enough to think about, I hope. So now let's factor 100. This term right here, it's going to define your first term. Why? Because AB, well, of course, that's 100. Because you're multiplying all this times 100. Of course, this might give you like an extra 50, but that 50 is not going to influence your first term. We already set up the conditions here. So AB plus A plus B divided by 2 is your first term. So now let's use this to get some examples. Let me just copy it. If I could just copy it. Okay. Copy. Make it a little smaller. Okay, so these are our conditions. Actually, also let me highlight this as blue. I'm not sure how to do that. Okay. Because remember, that defines our first term. So now let's do some examples. 35 times 75. Okay, so what's our first term? A times B. That's 3 times 7, which is 21. What's A plus B divided by 2? Well, that's just 5. And that's just 26. Okay, now let's think of the condition. A plus B. That's 10, which is what? Even. And there you go. There's your answer. Now let's do another example. 85 times 25. Okay, now let's use 55. Okay, so now what's A times B? Well, that's just 40. What's A plus B divided by 2? Well, that's 13 divided by 2, 6.5. Ignore the 0.5. You get 46. Now remember, that 0.5 is going to come back to haunt you. So that's when, because remember, 8 plus 5 is 13, which is an odd number. So that 0.5 makes a 25 into a 75. And there's your answer. There's another way to think about these types of problems. If you remember the previous video, not sure you saw it. Let's say 25 times 35. Well, what's the distance between them? Well, like, they both have a number that's in between them, which is what? 30. And how far away are they from 30? 25. I mean 5. 5 squared, 25. So as you can see, that's another way to apply it. You can also apply that method to here, and you can even combine that method with the first method discussed here. Like, let's say 55 times 35. The number in between them is 45. Hopefully you know that 45 squared, all you have to do is 4 times 5, 20, 20, 25. Because remember, just look at the beginning of the video. And how far away are they from 45? 10. 10 squared. So it's just 19, 25. So just remember, there are actually multiple ways of thinking of the same problem. Not just one way. There may be other better ways that you can figure out on your own. I hope you guys enjoyed. Have any questions, leave them in the comments. And also comments or concerns, also leave them in the comments. And I guess I'll see you guys next time.